Shapiro is an iOS and Android developer who has been building native apps since 2010. She maintains the Apollo GraphQL SDK implementation for iOS. I started using it not a long time ago as a total beginner, and I can confirm that it's amazing, the documentation and everything. It even generates the code for you once you have the GraphQL schema. Ellen is the co-author of the Ray Wenderlich Kotlin Apprentice book, and she has been written and edited many tutorials and other books for the site as well. She is also a co-author for the Swift for Good book, a project started by Paul Hudson that raised over $60,000 for charity. When not coding, Ellen can generally be found traveling, biking all over the place, playing sous chef with her wife Lilia, and relentlessly Instagramming her cat. I heard her cats have their own Instagram account, so feel free to follow that. So Ellen, please feel free to take it over and tell us everything there is to know about GraphQL.
Okay.
Stop
Can
sharing.
you all see it?
Yep.
Okay. Let's see. Let me find my correct thing here. So yes, thank you very much for having me today. So I really appreciate the invite, and I'm really particularly delighted to share the stage again with Craig, who once saw me find out about 10 minutes before a talk that I was giving that it was a 20-minute slot and not a 45-minute slot like I had prepared for. And then I proceeded to give my talk so fast it sounded like I was trying to auction cattle. Yeah, I was gonna say, I think I could tell you remember that one. So anyway, I work for, as I said, a company called Apollo GraphQL, and I build and maintain the iOS SDK. And when I tell people this, people generally have one of two reactions. They're either insanely excited because they've already really bought into GraphQL, or they're wondering what on earth GraphQL is, either because they haven't heard of it, or more often because they have heard of it because it's a tech buzzword, but they don't actually know what it is or what it does. So this talk is more for the second group of people, and I want to go back to the beginning and start with a really basic question, which is, what is a graph? For the majority of the population, when you say graph, they think of something like this, where data is being displayed visually on labeled vertical and horizontal axes. And those kinds of graphs are cool, but the more relevant question is what a graph is in the context of GraphQL. When we talk about a graph in GraphQL, we're talking about a mathematical concept called graph theory, which has also been brought over into computer science. The basic concept in computer science is that graphs are used to represent networks of communication, data organization, computational devices, the flow of computation, etc. Okay, you know what? You all did not come here to listen to me read you Wikipedia as you desperately fight to stay awake. So let's look at a couple of more concrete examples of graphs. The first concrete example of a graph representing data is email. In this diagram, there are circles that represent both the users and also the emails those users send to each other. And the way that each of these relates to each other is represented by the lines which connect them. If you look closely, though, you'll notice that in this case, these aren't lines, they're arrows. That's because the relationship between a sender and a recipient, the sender always sends to a recipient. There's always only one direction things can go. And this is unsurprisingly called a directed graph. Another kind of graph you may be more familiar with is something like Facebook or LinkedIn. Each person has to agree to connect to the other person, and then once that connection is made, things can go either way between the two people. And this is called an undirected graph. And you can see that both kinds of graphs have two general things in common. The nodes, or individual pieces of data in which both diagrams represented as circles, and the edges, or the relationships between the pieces of data, which were represented by arrows in the directed graph and by lines in the undirected graph diagram. And particularly for those of you who have previously done a lot of work with core data or other relational databases, this may sound a little bit familiar. This sounds just like the entities and relationships within a core data database. And clearly there are some similarities. But does that mean that a relational database is a kind of a graph? Well, there's some important differences. The biggest of which is the focus of how data, where the focus of how data is structured lies. In a relational database, the focus is on the nodes and relationships are somewhat secondary. And this is something that core data actually abstracts away from you. But you can see if you compare the entities, which is in this little sample are a launch, a mission, a rocket, and a user, with the underlying SQLite database created by core data. You can see those 4 entities get their own tables in the database. But before you start getting to the Z underscore metadata tables, there's one more, and it's the passengers table. And if you look back at the core data diagram to find out where passengers came from, you can see that it's one of the sides of the only many-to-many relationship in this model. While core data itself is capable of glossing this over, relational databases are focused only on single relationships, not many-to-many relationships, and certainly not traversing relationships over and over and over. This is instead what graphs are focused on. How is the data that you have related to other data you already have? And how can you traverse that data to find the data that you want? For example, if you have a social graph where each person has information about various relationship edges to person nodes, you can do things like request the user's father's best friend's oldest child's middle name. Now, how do we find out about these relationships? What are the nodes that are going to be available to you and the edges you can follow in the graph? The answer is GraphQL, which I'm sure, given the topic of this talk, is a huge surprise. The QL there, similarly to SQL, stands for query language. It's a way to ask the graph about what it's got. So now that you know what GraphQL is, you might be wondering, how do I actually use this thing? How do I find out what to ask for and how to ask for it? And I'm going to be giving some examples using Apollo's sample server, which is the result of our full stack tutorial, and which gives information about various SpaceX launches and allows you to pretend to book a trip on one of them. So the first thing to understand is how GraphQL tells you what you can ask for, and that is through the schema. The schema is a definition of every node available to you and what properties it has, including properties that are essentially other objects, meaning that there's an edge connection between them, as well as what operations are possible. The basics thing the schema does is define what it's possible to ask for, written as a sort of contract. And the schema is often written in a language called schema definition language, which is pretty similar to TypeScript, which is a thin typing layer on top of JavaScript. So here's part of the schema for our sample server, which again lets you learn about SpaceX launches and pretend to book a ride on one. And one thing you'll notice real quickly is that this part of the schema is all about defining types. And this is where Swift developers get really excited because we really love the ability to have type safety. There's no more question of what type a particular item is going to be when it comes back from the server because there's a defined type it should be in a contract. So if that's going to change, the schema would also going to need to change. Now, you don't want to go around creating types out of absolutely nothing. So you'll notice that there are a few common types that, not coincidentally, line up fairly well with what you can get from JSON. And these are called scalar types, and they're basically the base level building blocks of the type system. You can build types out of these scalars, then out of those types, then out of those types, and you get a fairly comprehensive type system pretty quickly. Now, one thing I do want to warn about is how optionals work with GraphQL, which I'm going to do in the form of a pop quiz. Sorry if this gives you terrible flashbacks to college. So the question I am asking is the following type optional? And the type is string with no annotations. And the answer, of course, is that it depends on whether you're working with Swift or schema definition language directly. Now, you may think that I am trolling you horrendously because it depends is a massively senior developer answer. But the fact of it is that there's a difference between Swift and GraphQL when it comes to optionals. In Swift, if you want something to be non-optional, you just write the type name with no annotations. For GraphQL, the way you annotate something as non-optional is to give it an exclamation point. And I know all of you good Swift developers are slightly horrified by this since you've been well trained to run screaming from force unwraps. But the reason for this is that in GraphQL, types are designed to be nullable by default. So you need a different kind of annotation to indicate that a particular item is nullable. So you're going to have to get used to that exclamation point not being wrong. Now, if you do want something to be optional, in Swift we have our good old trusty question mark indicating, well, we're not sure whether it's there or not. And since things in GraphQL are optional by default, that means optionals in GraphQL have no annotations whatsoever. This is definitely annoying to deal with, but at a certain point, if you work with it for a while and or have a big enough glass of wine, it basically makes sense. Now, once your types are defined in the schema, it's time to define what operations you can actually do with them. This is basically defining where you can start getting into the graph. And there are three types of operations in GraphQL. A query allows you to say, please give me this data. In the case of our sample server, you can get information about launches in general, a specific launch, the current user, and how many trips have been booked in total. Now, a query is by far the most common type of GraphQL operation, to the point that the words query and operation are often used kind of interchangeably, even though one is more of a subset of the other. This is true even in Apollo's docs, which we are working on fixing, but it's a really, really common thing throughout the GraphQL ecosystem, so it is worth being aware of. The next most common kind of operation is mutation, which allows you to specify how you would like data to be changed, then gives you back the result of that change. In this case, you can book or cancel a trip and then receive a typed response in return that you can get whatever information you want from that. You can log in and get an auth token as a string, or you can upload a profile image and get information about the current users. And all of these are one-shot deals. You ask the server to make the change, it makes the change, and then gives you back whatever you asked for. If you want something that updates more often, you want the third type of operation, which is a subscription. A subscription allows you to be proactively updated when data changes on your server. Under the hood, this is usually done by WebSockets, though it doesn't necessarily have to be. Speaking of doesn't necessarily have to be, subscriptions are a really cool trick, but you need to be careful because not every server provides proper support for them, and you can really get yourself into trouble if you're not careful. So now that you know from the schema how things are related to each other and what you can ask your server for, it's time to learn how to ask for it. So we're going to start with something that's actually baked into almost every GraphQL server, and that is a tool called Graphical or GraphIQL. Nobody really seems to be able to agree. But for the purposes of what we're doing today, I'm going to call it Graphical. Now, one small piece of background to understand is that instead of having multiple endpoints the way that REST does, there's only one URL for GraphQL, since the way you ask for things is defined quite differently. And I'll be walking you through how here in a bit, but for now, it helps explain why for almost every GraphQL server, if you load the GraphQL endpoint in a browser, you'll see this page or something like it in dark mode, which is the graphical tool. On the right, there are a couple of tabs, one of which shows the schema itself, and the other one of which shows the documentation generated from the schema automatically. Next, move in the upper left-hand section and look at how you actually write an operation using GraphQL. So the first thing that you have to do is declare this is, in fact, a query. That way you're distinguishing versus a mutation or a subscription. Next, you can add parentheses to allow you to pass in one or many variables. The bit with the $ prefix is the name of the variable. The ID is the type. And again, that exclamation point is saying that this is a non-nullable type. Next, you can start making the query. Now, remember, there's a list of possible queries that are defined in the schema, and this is using one of them. The unannotated ID is the parameter name. The ID with the $ in front of it is the variable that you just declared above. And you can see from the query definition that the type returned will be a launch. So you can use the definition of the launch type to see what are the properties of the launch and then access them at that level. And then finally, you can look at the properties of the custom types like mission and rocket and use those to pull out whatever properties you want of those types. So now you have a whole query, and you're probably wondering how to pass in that parameter that I talked about earlier. In Graphical, the answer is that there's a little section below the query section where you can specify variables in a dictionary. In this case, there's a little secret. ID is actually just a type alias for string, so you have to pass in the identifier as a string. Next, moving back out to look at all of Graphical, you'll see that big old play button right in the middle. And now that you've got a written operation along with the parameter that you're passing in, you can just go ahead and smash that big old button to actually run the query, and you'll see the result pop up in the right-hand panel. Now, one thing I want you to take particularly note of here is the shape of the response. The JSON that's returned matches the shape of the query absolutely identically, along with the names of the properties in JSON. By creating a query in a certain shape with the field names prescribed by the schema, you can know exactly what your response is going to look like. Now, I want to take a brief detour here to ask how would a REST endpoint do this? Because this is one of the major things that actually drew me to GraphQL in the first place. And I want to compare the way you can do this with GraphQL to this REST endpoint from the open source RSpaceX API that allows you to get data about a specific launch. And these are basically the same launches we're fetching data for using the Apollo version of this API. When you call a get on this endpoint that says, give me the information about the latest launch, you get literally everything you could ever possibly want to know about the launch. I had to zoom GitHub way out to even be able to get a screenshot of the response JSON. And really, if you're only going to be using the mission and the rocket name, that is way too much stuff. With REST endpoints like this, you're going to waste your user's networking allotment and battery on a whole ton of data that you're immediately going to drop on the floor. With GraphQL, you're able to get exactly the data that you need and only the data that you need. And frankly, that is a lot better for everyone. And even if you decide when you look at the response, you know what, I don't like the name of this field called site. I want it to be called something else. You can do that really easy by doing something called aliasing, which allows you to change the name of the field that's returned to you. So now that you've got a schema that defines what it's possible to ask for and a query that defines what you're specifically asking for, it's time to do some validation. So are you going to tell your code that it's awesome and that so that it really feels better about itself and it builds on the first try? No, you are not. Validation is the ability to compare your operation to your schema and find out before you even lift a finger if what you're asking for is even possible. So GRAPHQL is real nice about this, and it allows you to, when you hover over that little red spot, get an error message that tells you exactly why something won't work immediately as you type. But what if the same thing that powered this could validate, maybe not as you type, but could validate GraphQL operations that are in your Xcode project? And that once your operations were all validated, you had enough information with the types that are defined in the schema to generate all the code necessary for doing all of this in Swift, including the parsing code. And that is where the Apollo iOS SDK, which is maintained by some smirking doofus, wait, shoot, that's actually me. Now, one thing to be aware of that's specific to Apollo code generation is that this query we've been working on is called an anonymous query because it doesn't have a name. In order to generate code that works with this query, we need to give it a name. I'm going to show you what we do with that name in a version of our generated code that essentially leaves out a bunch of the really messy stuff we're doing under the hood to make all of this work right now. This is also hopefully going to be much closer to how this will work once some ongoing work in the code generation is completed. So here are the nested class and structs that are created for the operation that we've been looking at. The operation was named launch info, and it was a query. So the code gen automatically appended the word query to the end of it to make it clear in the class name what we're doing. The parameters name and type are both pulled from the queries declaration so that you can initialize it like a normal Swift class. Next, we have a nested class called data, which holds the parsed result from the server. Now, you may be wondering why the return value here is optional. If you look at the definition of the query, you'll see that launch is unannotated, which means it's optional, which makes sense. If someone were to pass in an ID for a launch which didn't exist, you'd want the server to be able to return null for that. Anyway, that launch is of a type that's nested within launch info query. Why is it nested? Because it contains only the properties that were asked for in the launch info query. There are other properties on launch after all, but these are the ones that you asked for. You can't even try to access the isBooked property on this object, because even though that is a property that exists on launches in the schema, it is not a property you got info for with this request. So this helps you figure out really, really easily when you need to add new fields to your query. If you need a piece of data that's not on the object, you need to add that field. And that's the same reason that the mission and rocket types are nested as well, to allow that level of granularity. And the best part of all of this is that you don't have to write this code. Apollo iOS will generate it for you. And that is the case for every single operation that you hand us. The more stuff you switch from a REST endpoint that you're building out the boilerplate for yourself, the less boilerplate that you will personally have to write. You also don't have to write a URL session wrapper that properly formats everything to send it to your GraphQL server, then parses the return values out of JSON into these generated types, because I just spent the last 2 months rewriting that feature to make it more robust. You're welcome. Now, there's not a way for me to write everything you need. You are going to have to write some code. And this is what it's going to look like. You have an Apollo client instance that you use to do operations. You hand it your constructed query, and then it goes out to the network and gets you a Swift result. which, like any Swift result, you start by switching on to see what you got. And here, if you've got a failure, it's generally either something that happened at the URL session level with loading or some kind of parsing error. And you can handle that error however you want, probably doing something better than just printing it out like I am here. In the success case, you actually get a GraphQL result. Now, wait, that seems a little excessive. You got a result that contains a result. Why is that? And the answer is that GraphQL allows you to return partial results when part of a query works, but another part of it didn't. So imagine in our world here that you're able to get most of the information about the launch, but for some reason, the data for the rocket couldn't be loaded. And importantly, rocket is a nullable property. In that case, you get an error about why the rocket couldn't be loaded. Maybe the microservice or database that deals with rockets is having an outage. And you'd also get the rest of the data that you've asked for since it was possible to get it. Now, this optional chain here leads me to one quick pro tip, which is that you can use Swift extensions to allow you to handle nullability gracefully from the final call point. Now, you'd have to add this outside of the generated API files, which are constantly overwritten, but you can add an extension that turns a nullable property into a non-null property relatively easily, or moves things up to a higher level for better readability. Now, that's really getting down into the nitty-gritty of how to use things. So I want to zoom way, way, way back out for the last few minutes of this talk, because now that you know how it works, it would probably be helpful for me to outline what GraphQL is really good for. I've already covered a big piece of this, which is that you can much more easily get the data that you want, and only the data that you want, and not the data that every single application that would ever want to use a specific endpoint ever needs. Another benefit of this is that adding stuff to a graph is much, much, much simpler than adding things to a REST API. And I have had this experience quite a bit personally. I suspect so have you. And there's a field that's available publicly on one endpoint, but I need access to it on a second endpoint because that's the one we're using for a particular screen. And we say, okay, can we take the field that's on this one endpoint and also make it available on the second endpoint? And the backend team says, oh yeah, sure, we'll put that in the backlog. And then there's some kind of site emergency and the project manager prioritizes a new feature that the CEO wants, and it takes a month or two just to add a piece of data that's already available in public to a different endpoint. With GraphQL, anything that's available in the schema can be accessed by relationships in the graph. If you remember this example, the graph here only has to know that a person can have a middle name and that each of these relationships are possible. And you have a way to tell which of these relationships are optional and which ones are not. Adding something to the schema means it's available everywhere in the graph you can traverse to, given the relationships between the pieces of data. So those are some pretty compelling pros. Let's talk about a few of the cons. Because GraphQL is a really sweet hammer, not every problem is a nail. It does not mean that the GraphQL community hasn't tried quite desperately to make it into a nail, which is the case with things like uploading files. Because GraphQL is designed to send much, much smaller bits of data around, the community came together with a standard that has a specially named type that allows you to create a multi-part form request to upload a file with a mutation that can replace various temporarily null parameters with the uploaded file on the server at runtime. The problem, as with all mad science, is that while this is technically possible, it's really a stretch to say the uploading itself should be part of the graph, and it's super, super error prone. A much, much better way to handle uploads in GraphQL is to continue to use whatever method you're already using to upload files, whether it's just a REST call or using something like the AWS SDK to upload to a specific bucket. And then whatever you're doing should return the URL of where the uploaded file will live. Once you have that, you can send that to your graph as a string much more easily. And you will have way, way fewer problems in your life. Another thing that's not a huge advantage of GraphQL is working with highly optimized queries. This is when your backend has tuned the hell out of everything, removed every unnecessary field, shaved every millisecond off the database that it possibly can. In that case, REST can be faster. Now, there is a lot of tooling around GraphQL, including a whole bunch made by Apollo, both free and paid, that helps you figure out where bottlenecks are in the actual requests that are being made and executed there. But while you can use that to find bottlenecks, you can never completely eliminate them and still have the kind of flexibility to allow people to request whatever they want. This is absolutely a trade-off that's worth being aware Speaking of trade-offs, while adding stuff to GraphQL is much easier, it's much harder to completely remove things. Because while the ability to easily add things to the schema and the availability of anything in the schema to anything querying it means that versioning isn't necessary, it also means that versioning isn't really meant to be done with GraphQL. So how do you remove things? Because there may be clients that are relying on fields that are in the schema that can't be changed. You always have to start by deprecating fields in the schema before removing them. And Apollo iOS takes that deprecation annotation from the schema and adds a Swift warning for you when you're using a deprecated field to try and tell you to stop doing that. But your server team still has to look at actual usage after something's been deprecated and wait until nobody is actually asking for that field before actually saying goodbye to that field. The good news is that it's much safer for clients. The bad news is that just removing something becomes a whole procedure. Another good thing that GraphQL isn't always good for is keeping your security super simple. And as you may have already guessed this, because when I say that if you can have access to a graph, you can ask for anything on it, developers get really excited about this. However, the security teams tend to be somewhat horrified, because if you're just used to being able to slap a 401 unauthorized on any endpoint that needs to be protected, the fact that GraphQL has only one endpoint means that you are not going to be able to just return that kind of status code willy-nilly. You're going to have to think on a more field-by-field basis of who should have access to what, and work with your backend team to make sure that that actually works well for everyone. Oh, and here's a security pro tip. Schema introspection is generally on by default for GraphQL servers. What that means in practice is that anyone who knows the way to ask for this can get your GraphQL server to return information about its schema and can get your schema really easily. You probably want to make sure that there's some kind of API key set up as a blocker to getting that information. So we have reached the obligatory summary slide, the part of the talk where I'm going to try to tell you what I told you in a way that makes you remember some of it. First, a graph is a way of thinking about data pieces and how they're related. GraphQL lets you ask for information about what is in your graph and how it's connected, which is defined by the schema, along with the types and the relationships between your pieces of data. You can then use operations to specifically ask for only the data you need and receive only that data back. And remember that as with any tool, GraphQL has a lot of stuff it can do really well. That is not literally everything. Be aware of its strengths and its weaknesses and use them wisely. If you're interested in trying out our iOS SDK, we've got a tutorial available at this URL. And I am now happy to take any questions. Thank you very much. Ooh. I'll leave that up for a second for people to screenshot it. All right. In 3, 2. Thank you. So yeah, does anybody have any questions?
Yeah, thank you. Anybody can unmute yourself and just ask the question.
Can you share that URL one more time? I didn't screenshot it correctly.
Yeah, I'll throw it into the Zoom chat. Apollo tutorial. All right. Boom. So yeah, so that link right there should take you to the introduction to our tutorial, and that'll work you through some changes. Oh, haha! I just put out a new version and I forgot to update the version that this is working for. So this is now up to date for our most recent version of the iOS SDK, which is 0.36.0. So, and yeah, like if anybody, there's definitely a part of the tutorial where I kind of, I got to a certain point in working on it and then I got pulled onto something else. So it goes up to basically, you'll sort of see when you get to the point where I kind of dropped off for a little bit to work on other stuff. But I've been really trying to keep this up to date and make sure that this is working with all the current versions of the SDK so that people can really get the hang of setting all this stuff up and getting it building. Anybody else?
I tried GraphQL maybe 1 or 2 months ago without knowing anything, and I can tell you that it works. It worked perfectly. And at one point, I hit a roadblock, and I Googled, and I got to a forum, and I reached an answer from Ellen that helped me fix it. So
I've been at Apollo for about a year and 4 months now, I think. And like one of the big things that I've really been trying to do is really be an advocate for us with developers. I am always happy to answer questions. You know, just always feel free to reach out to me on Twitter or whatever. You know, I love talking to people. And it turns out when you put an extrovert into quarantine for 7 months, they're like, people. So it's definitely I'm always happy to talk to anybody about it.
Ellen, I have one quick question. Oh, sorry.
Yeah. No, go ahead, Mike.
Okay, so there's nothing that is there anything that the backend server guys would have to make changes to, or does that just stay the exact same REST calls?
So there's a bunch of different ways that you can set it up. We have the server stuff I'm at least marginally less familiar with, just because I work almost entirely on the iOS and Android stuff. Sure. But there's ways where you can sort of set up GraphQL queries to actually under the hood make a REST call. And that's a way that a lot of sort of larger organizations take GraphQL for a test drive, because it means that they don't necessarily have to like turn everything off immediately. And they don't have to do necessarily the work to move everything to like GraphQL resolvers, which is a different type of way of interacting with your database than I think some of the SQL resolvers that you would have for like a REST endpoint. So it's definitely something where, you know, it is something where one of the things, at least at Apollo, that we try to tell people is like it's not necessarily a thing where you have to have everything be one or the other. What we've seen be really, really helpful is for GraphQL is either using it when your company is really tiny as a way to sort of much more quickly evolve your schema. It's also really helpful when you have a very large corporation where you can sort of use GraphQL to avoid the sort of communication backlogs that I was talking about earlier, where just you can't just like turn to the server person next to you and be like, hey, can you add this? It's like, okay, I have to get this prioritized and have 17 people sign off on it. It's like that makes it really, really, really hard to iterate on things. And so yeah, so that's definitely a possibility.
Okay.
And then I want to answer there. Weifang Li asked a question in the chat that I want to address, which is, if GraphQL is not secure, will enterprises use it? What is the use seen of it? I think I would not say that GraphQL is not secure. REST is not secure out of the box either. It's just that applying a 401 to a particular endpoint is a much simpler process than saying, okay, we have this person who's asking for this information. Are they actually allowed to ask for this information on every single query? And it's much more a question of just sort of like resources and what people feel like putting some time into. And honestly, like we have some very, very, very large clients using this. I'm trying to think of which ones are actually publicly known. I know the GitHub mobile app, they just wrote a blog post about how the, yeah. Is that Craig? Is that you?
Yeah, NFL, NBA, NHL, they're all using it.
Yeah, there's a lot of different places that are using it, and I think it's something where there's nothing that's secure out of the box, but I think there's, you know, with REST, there's a lot more existing packages to deal with authentication and things like that. Whereas, you know, obviously there are some to deal with that for GraphQL, but is because GraphQL just hasn't been around as long as REST, it's not the like really wide variety of stuff that you can do in any language at any point. And I think that's something to be aware of as a potential trade-off. So, but yeah, like I think saying GraphQL is not secure is not quite correct, but I mean, computers are not secure if you don't do anything. If you don't put a password on your computer, people get into it. So the question is sort of how much work do you want to do around security in order to actually make things the level of secure that you want or need them to be. Because yeah, we've definitely got some clients that are using it for like HIPAA and financial stuff, which is like regulated out the yin yang. And so it's definitely stuffing where you can make anything secure. It's just a question of like, is it more effort than just saying yes or no? Let's see, from someone who's named me to everyone. Which one do you prefer personally, GraphQL or REST? Personally, I prefer GraphQL, but I also don't write servers. I think it is something where the brief work that I've done on servers, I've only messed around with REST stuff. But from a standpoint of what is easier for me to work with as a developer, I really greatly prefer GraphQL. I've really been excited about this, and that's why I jumped on board with these guys. So
okay, let's see, maybe one more question, if there is any.
Otherwise, we can throw it from the frozen tundra up here down to Florida.
Okay, Ellen, so if they want to find you, they just Google you.
Literally, that's where you find her.
No, you can find me on Twitter. You can find me on Twitter at Designated Nerd. Also on GitHub at Designated Nerd. If you just Google Ellen Shapiro, you're going to find me, but you're also going to find like the head of NYU's pediatric urology department, and like apparently this was hilarious. I did a vanity Google the other day for reasons that I can't even remember. And I discovered that there was someone whose name is Ellen Shapiro, is like a third-year lawyer at some firm in New York City, and she like went to Harvard and stuff, which like
that's you.
No, I think that's my dad's actual kid, because like that's completely the life that my parents wanted me to have. So I'm gonna be like, Dad, do we need to talk? I think we might need to talk. But yeah, like Designated Nerd is definitely the best way to find me online. That's I use that handle all over the place. So.